Question 12 from topic chemical reactions. Similar question you will find in chemical reactions, in which normally investigating either a rate or a speed of a chemical reaction by measuring the volumes or the time for a printed text to disappear if the precipitates are formed. In the questions, a teacher investigated the rate of reaction between two solutions J and K and a sulfuric acid at different temperatures. Four experiments were carried out. The experiment one was a large measuring cylinder was used to pour 50 cm cube of distilled water and 40 cm cube of a sulfuric acid into a 250 cm cube conical flask. Then a small measuring cylinder used to add 2 cm cube of methyl orange and 5 cm cube of solution J to a mixture. The temperature of a mixture was measured. The reaction was started by adding 5 cm cube of solution K to a conical flask and immediately starting the timer and swell the mixture. The time taken for a mixture to turn light yellow or pale yellow was measured. The final temperature of a mixture was also measured. Then experiment 1 was repeated by the mixture of a conical flask was heated to 30, and before adding solution K, the temperature of a mixture was measured, then 5 cm cube of K was added, and the timer was started and the mixture was swelled again. Then the time taken for the mixture to turn the light yellow or the pale yellow was measured. Then experiment 1 was repeated now at 40, then experiment 4 was repeated at 50. Use stop clock diagrams to record the time in the table and work out the average temperatures. Just a minute, I will zoom out, then you can use screen annotation to complete this. Use the time for a mixture to turn pale yellow or light yellow and the average temperature. So first one is 128. The second one is 58. The third one is 27 and the fourth one is 18. And we have 16, 27, 41, the average temperature, and then 50. And we have the grid. Plot the results on the grid and draw a smooth line graph. So smooth line graph means we don't have to use a ruler. For a smooth line graph, you don't need a ruler scale, just point-to-point connection you have to make. So what we have, the 120, this was time and the average temperature. So this one is for time, which is in second, and the average temperature was there. So first, 16. And 128. 10 boxes equals to 20, so each box is 2. So first I'll move from 10. So 122, 4, 6, 8, 128, and then 1, 2, 3, 4, 5, 6. So this will be 16 and 128. And then 58 and 27. So I'll move from 20 here and 62, 4, 6, 8, and then 1, 2, 3, 4, 5, 6, and 7. Then 27 and 41, 27 and 41, so we have 40 here. And this is 20, so 22, 4, 6, 28, so this will be 27 and 41. And the last one is 18 and 50. So this one is 50 and 20, so this two boxes, this is 20, so this will be 80. So two boxes are representing. So this is our first point. This one is a second point. This one is a third point, and this one is a fourth point. And we have to join. Draw the smooth line graph. So we just have to join points to point. Don't use a ruler scale. Freehand graph you have to draw for this. So this one is a graph for the results. From your graph, deduce the time taken for the mixture to turn pale yellow or a light yellow if experiment 1 was repeated with an average temperature of 60. Look, we don't have the value for 60, so what we have to do, we have to extend our graph, like follow the pattern. The last point which we were having, that was 50, so we just follow the pattern and find how much is the temperature change accordingly. So it was, each box is representing 2, 1, 2, 3, 4, 5, 6. So this will be equals to 12. So we'll make, and you have to show clearly on the grid. So you have to work out, like you have to extend, then this line should be there. And the 1 mark is for writing the answer, 1 mark is for showing this on the graph. So it's 12 seconds. Then in which experiment was the rate greatest? So which experiment the reaction was faster? Experiment 1, 2, 3, or 4?
No, 4, because it took less time.
Yeah. So it took a shorter time as compared to any other. So we'll write 4. Then why the rate of a reaction was greatest in this experiment? Why in experiment 4 the reaction was fast? As you can see, it was a different high average temperature or the temperature at the experiment 4 when it was done, the average temperature was 50. So it was a high temperature as compared to any other. So you will mention this in a reason because
Higher
it was
temperatures, so
higher
particle
temperature.
reactant particles which are colliding have more motion
Yeah.
and react far more
Yeah, greater number of successful collisions will be there,
more
great,
effective collision.
more effective collision. So 1 marked because it was a high temperature, and at high temperature, what is the effect of high temperature? That the particles will have high speed, or there will be more collision, or there will be greater proportion of the molecule which are having energy more than activation. Suggest and explain the effect on the result using a burette to measure the volume of solution J. So what is suggest and explain? So usually on the time, it won't have effect. Like not too much difference is there. Like example, if you measure 30, if it is 29 point, on the time, it won't affect too much. But only thing what happened, the burette is more accurate in measurement of volume compared to measuring cylinder. So overall time negligible effect will be there. There will be a very slight effect will be there. But when you write even the marking scheme, you will find the answers are not given for relating the experiment. It's like it will be more accurate because compared to measuring cylinder, the burette is more accurate. 1 mark is for mentioning that the result will be more accurate if you are using a burette as compared to measuring cylinder. But overall time interval, it won't have too much effect on that. Only measurement of the volume will be more accurate. Then the last part, suggest and explain other improvement to this experiment. Usually, like example, as you can see, when we are carrying out this reaction, we are changing a temperature, and like we are doing it at a different temperature. So what might happen when the mixture is hot, the mixture will lose energy to the surrounding. So if we want to prevent the mixture to lose energy to the surrounding, so what
Insulation.
we can use insulation, we can put a lid.
We can paint the container,
Yeah, or you use a container using insulation or
lag it.
using lagging or insulation, we can also use. Or even like example, if you are using a stop clock or a stopwatch, so digital timer can, well, as you can see, this one is a stop clock is there, so we can use a stopwatch or a digital timer. Like this is analog, so we can use any digital timer or digital thermometer. So we can use lid or lagging, or we can also use digital thermometer or the stopwatch. Is it clear, this question?